Hi, we are Team TBD and we're working on parking problems. I'm Deanna and I'm a Course 1 undergrad.
I'm Jocelyn, and I'm a Course 2A undergrad.
Our project is set in the city of Austin, Texas. In Austin, throughout the year of 2016, a pay for parking by phone app was implemented in designated areas. This gave us the opportunity to analyze parking violation data in the year before the app was implemented and the year after the app was implemented. So in the year 2015 and the year 2017. The app is called ParkX. With this app and fast and easy registration, you can keep track of your parking session and pay via the app. With this project, we were able to use data analytics to potentially improve the lives of citizens, analyzing whether there was an increase or decrease in meter violations. This could show whether implementing the app helps citizens or not by asking the question, does implementing a pay-by-app system for parking meters reduce the number of parking violations in a city?
We are able to use a dataset on data.gov that lists information on all violations that occurred in Austin by year. Here, we were able to find the parking violation data from the year 2015 and 2017. Using this data, we were able to find parking and specifically meter violations and their locations.
For the map, we used Google APIs, a set of application programming interfaces developed by Google. The map's JavaScript API allowed us to customize our map, add a heat map of the parking violation locations, and overlay a polygon to show where the pay-by-phone app was implemented.
Now we're going to do a quick walkthrough of our code. So first off, we need to access the database. Here you can see we used an XML HTTP request to access the data from the data.gov database. Next, we need to parse the data. To pick out the parking violations from the rest of the data, we search for violations with offense case type PK. To further sort out meter violations from the general parking violations, we looked at the offense charge description. Looking through the data, we made an array of all the offense charge descriptions that indicated meter violations. We then compared each violation against this known list to see if it was a meter violation or not. Next, we needed to do geolocation to go from the street addresses we got from the database to the latitude and longitude coordinates needed for the Google Maps API. So first, we got the JSON object, street addresses, from the database and saved it locally as a JavaScript variable. Next, we appended Austin, Texas to each street address so that the latitude and longitude coordinates were more accurate. Next, we ran geolocate code based on a tutorial by Mike Williams to convert the street addresses into latitude and longitude coordinates. We saved these coordinates locally because we had to run the code very slowly in order to avoid getting an overquery limit from the Google geocoding API we used. In the heat map code, upon a button press, a function is called to go through this array of latitude and longitude coordinates and convert them into points on the heat map.
This code initializes the road map. Here, we also have code that allows us to display the number of meter violations for a designated year. In this code, we used a Google Maps polygon tool that creates a polygon with a given color, a given opacity, and a given latitude and longitude coordinates, in which the polygon can then inscribe to then demonstrate where the pay-by-phone app was implemented. In this code, we pass in data and make a heat map. Also in this code, we are able to call multiple data sets, the data set for 2015 and the data set for 2017, by taking in the variable data to display.
Next, we're going to look at a demo of our code. So here you can see the region in red is where the app was implemented. This is the 2015 meter violation data. This is the 2017 meter violation data. You can also see that you can change the gradient, radius, and opacity here.
Looking ahead, it would be great if in the future we could also analyze other cities, like Miami, Boston, Chicago, or LA. Finding a trend among different cities could then strengthen the meaning of our data.